this, or did you say it?
No, they. All right, so the title. The title of your notes is Completing the Square. All right. At this point, we're silent. We're just taking notes. So completing the square. When we look at completing the square, I'm going to give you a couple examples of what I mean by square, because I do not mean a four-sided figure. So examples of squares. Yeah, those are numbers that are perfect squares. 4, 9, 16. But squares for completing the square, what I mean by this is something like x minus 1 squared. That's my example of a square. So it's something squared. And what does it mean when I say x plus 1 squared? What do I mean by that?
There's 2 of those.
There's 2 of them, yeah. So that means I've got x minus 1 and another x minus 1. That's what that means. How do I multiply those out? You guys remember from last year? You can use the box. Or you can FOIL, yeah. Does anyone remember what FOIL stands for? Yeah, first, outer, inner, last. So, and your teacher might not have called it that. It's possible that they didn't. So first is x multiplied by x. What does that give you?
2x.
X times x?
X squared.
X squared. And then outside or outer is the x multiplied by the negative 1. What does that give you?
1x.
Yeah, negative 1x. I is for inner. What does that give you? Negative 1x. And then L is for last, so the last one times the other last one is positive 1. So we've got x squared minus 1x plus 1. And if we combine like terms, that gives us x squared minus 2x plus 1. So that's what I mean by squares, is this. So this is like the completed square form. This would be the standard form. Right? And we're kind of doing it backwards right now. What we're going to do today is we're actually going to start with problems that look like this, and we're going to make them look like this. All right, so we're going to do it backwards. All right, another example of a square could be like x plus 3 squared. So what do I mean by x plus 3 squared?
X plus 2 squared, x plus 3 squared.
Yeah, x plus 3 times x plus 3. And when I multiply that out, what do I get? You first? Okay. Yeah, and you're quick, right? Some people have done this a lot, so they're pretty good at it. So if I did the x times x, that's x squared.
X plus 3 plus x plus 3 plus 1.
Yeah. So that was 3x, right? And then another 3x, and that's where the 6x came from. Mm-hmm. And then 3 times 3 is the 9. So we get x squared plus 6x plus 9. Okay. So these are the squares. Square, square. So when we do the process of completing the square, they might give us a problem like x squared plus 8x plus, and they're saying, what number could you put right here that would complete the square, that would make it so you could write it as something squared? That's what completing the square process means, is what number could I put here that would allow me to write it like something squared. That's what we mean by completing the square. So for us to remember how to do this, we're actually going to draw a square, and we're going to complete the square because that's going to help us remember. So go ahead and draw a square on your paper. And we're going to cut it into 4. This is going to kind of remind some of you guys maybe of the box method. Other students said it reminded them of Punnett squares from like science classes. Yeah. All right, so we're going to put the x squared right here. And then if you look at these, we're kind of working our way backwards. If you notice this, it was 6x, but that was cut in half before we added it together. It was 3 and 3. And this part right here had -2, but before it was -2, it was cut in half to be -1 and -1. So we know that this 8x, before it became 8, it would have been split in half. So we're going to split it and put 4x right here and 4x right there.
Are you
So,
always gonna split it in
say it again?
half? Are you always going to split it in half?
So if I look at this, I have to think about like the outside. We're kind of going to do it like a reverse multiplication table almost. So if you think about the outside, this would have been x times x. That's how you got the x squared right there. And if we're doing x multiplied by something to get the 4x, then we must have had a 4 right here. And if we had x multiplied by something to get a 4x right there, then we must have had a 4 right here as well. And so now we can use that idea to finish, or to complete the square, and so what would we get? 16, yeah. And some of you guys might have figured that out already, so that's good. Yeah, and then you can look at the outsides. We can see x plus 4 is one of the outsides, x plus 4 is the other outside, so that gives us x plus 4 squared. So we've got two terms. There's two different ways of thinking about these numbers. This 16 right here is the number that completes the square. And the x plus 4 squared, the actual parentheses there, is the completed square. So 16 is the number that completes the square, and then x plus 4 squared is what we would call the completed square. Yeah.
Why do we want it in that format?
So for big picture perspective, this is going to help us get an equation from standard form into vertex form. So we'll look at problems where we do that. It's also your third method for solving a quadratic. So if you guys remember your cheat sheet, we said that our methods for solving quadratics were number 1, factoring. We always did that first because it's the easiest. Second, we would say another method for solving quadratics would be the quadratic formula, because you can solve literally any quadratic with that. And then we said our third method was completing the square. So those are like the contexts that we use this in. Yeah. And we're going to start today by looking at like more simple examples. We're not going to do super complicated ones today. Let you get used to it, and then we'll look at the more complex ones. All right, so we're going to look at a couple examples of how to complete the square. We want to get this to where it's maybe easy enough that it starts to seem boring. So if it starts to seem boring quickly, that's not a bad sign. So if we said x squared plus 10x plus something, we want to find the number that would complete that square. So I'm going to go ahead and draw the square. And I'm going to put the x squared plus, or the x squared here always. And then for the 10x, I know I've got to split it in half. So what do I get when I split it in half? Yeah, 5x is here, and 5x is there. So I know on the outside, x times x is how they got the x squared term. And then x times 5 would have been how they got the 5x. And then x times another 5 is how they got the other one. So what number completes the square? 25. Yep. All right, so that completes the square. And then what is the completed square?
X plus 5 squared.
X plus 5 squared. Okay, we're going to try one with some negatives in it. So we're going to do negative 12. So how many x's should go in each of these corners? We've got negative 12 total. We're going to split it in half, so 6, and we're going to make sure they're negative. So negative 6, negative 6. So x times something is negative 6. What's that something? Negative 6. All right, and then this is negative 6 as well. And what number would complete the square? 36. Yeah, and you guys notice it's positive 36 because you have a negative times a negative. So positive 36 is the number that completes the square. And then what is our completed square?
X minus 6 squared.
X minus 6 squared. Okay. Is it possible to do this with an odd number?
Yeah.
What would happen if you did it with an odd number? Decimals. Let's do some decimals. Oh. Alright, so we're going to do x squared plus 5x. We want to see what that would look like. Do you guys want to do decimals or fractions? Decimals? Okay. So if we take the 5 and we cut it in half, what do we get? 2.5. Okay, so 2.5x, 2.5x, and then we can write on the outside what we've got. We have x times x, and then right here we have a 2.5, over here we have a 2.5, and then what number would complete the square?
6.25.
6.25? Is that what we got? Alright. And then what do we get for our completed square?
X plus 2.5 squared.
Okay. Alright, now let's say that somebody gave us this problem, but they did not like decimals. What could we do?
Fractions.
They want fractions. Do you guys know how to switch them into fractions on your calculator? Okay, so type the decimal in. So if the decimal that we're looking at is 6.25, go ahead and type 6.25. And then if you hit the math button, it's right underneath the alpha button, hit the math button. And option 1 is frac. If you press enter, it will turn it into a fraction for you. So 25 fourths. So x squared plus 5x, and then we could say the number that completes the square is 25 fourths. And then we can take the 2.5 and turn it into a fraction, 5 halves. Okay. All right, let's do one more. Yeah.
So why are we finding the number in the square if we're just looking for the x plus whatever thing?
You'll see it in a second. Yeah, you're gonna need this number. You don't really need it for what we're doing right now, right? You can just see, well, like divide it in half. That's all you need. But for what we're doing next, you're gonna need that number.
Okay.
Yes.
So we can't leave it in the 2.5. You gotta have it in fact.
It depends. Depends on the instructions. Sometimes they don't care, and then you can do it however you want. But sometimes it'll be like, I'm checking my answer, and it's only in fraction form. I just want to make sure I have it right. So it's good to be able to switch them if you need to. Okay, let's do one more odd one, and then I'll show you the context we're going to use this in. So it will make the problems a little bit more difficult, but not too bad. We're actually going to do negative. So we're going to do x squared minus 3x. So what do we have? And then when we split it in half, what do we have? So, and we're going to make sure it's negative, right? Negative 1.5x, negative 1.5x. And then if we multiply that by itself, then that's 2.25. I'm going to turn this light back off. There we go. All right, so the number that fills that in is 2.25. And so would it be written as a completed square? Okay, and then I want you guys to go ahead and take that and turn it into fraction form. So I want you to just rewrite the same thing but have fractions instead. Okay, so x minus 3 halves squared is what we have there. And then my blank is real slanty. And then what number completed the square in fraction form? So 2.25, if you turn it into a fraction, what do you get? 9/4. Okay. Perfect. That's a 9. All right, how do we feel about the process of finding the number to complete the square? Can we do that? And then write it in completed square? Okay. So what we're going to do next is we're going to take this process and we're going to use it to take an equation from standard form and put it in vertex form. That's the point. That's what we usually would like to do with this. So we're going to say completing the square to put an equation into vertex form. So the problem that we're going to start with is we're going to say y equals x squared plus 6x plus 3. So if we think back to the problems that we just did, do we want that 3 sitting right there? Did we have a number in the problems we just did? No, we didn't. So we're actually going to take the 3, we're going to move it over with the y, and we're just going to kind of ignore it for now. So I'm going to have y minus 3 equals x squared plus 6x, and this is where I'm ready to complete the square. I can go ahead and figure out my blink now. So I have y minus 3 equals my square.
Was that an erasable pen?
No, this is a mechanical pencil.
I thought that was a pen.
Yeah. My pencils are fancy. So this is an x squared. And then what do I put in these two? 3. So I've got 3x and 3x. So what number would complete the square? 9. So I am adding 9 to the right side of an equation. What should I do on the left side? Add 9, right? Whatever you do to the right, you also do to the left. So I added 9 to the right, so I'm going to add 9 to the left. So now on the left side, I have y, and then what's negative 3 and positive 9? 6. So I've got y plus 6 equals, and how can I write this side now that I've completed the square?
X plus 3 squared.
X plus 3 squared, okay. What do I do to get the y alone? Subtract the 6 back over. And now we can say it was in standard form to start with, but we're in vertex form now.
Whoa.
So that's the purpose of completing the square, is to be able to switch it from one form to the other. That's our process.
Can you pause right here?
You just need a break. So example 2. Y equals x squared minus 8x plus 7. So, do we like that 7? No, what should we do? Minus it over, right? So I have y minus 7 equals x squared minus 8x plus whatever fills in the blank. And then we draw the square. So y minus 7 equals, I got the x squared right here. What do I put in the two corners? So negative 4x, negative 4x. So what number would complete the square? 16. And if we add 16 to the right side, what do we have to add to the left side? 16. So we've got y plus 9 equals minus 4. So we factored it.
Minus 9, right?
And then we minus the 9 over. What I ran into with second period is they kept forgetting to move this number, to do the opposite of this number to move it over. And they kept doing it in their heads and then getting it wrong. So just watch out for that. That's done. We got our vertex form. Okay. How do we feel?
Nice.
We got it? Kinda got it? Okay. Here. So, we've got one more thing to learn today. Are we ready? So, the next thing that we're going to use completing the square for is we're going to use it to solve. All right, so we're going to solve equations by completing the square. Alright, so the process of completing the square is going to be the same here, but we're going to be solving for x, so that means that our final answer is going to be x equals a number. So our final answer definitely looks different, but the process in the middle is going to be the same as what we just did. So our first example is x squared equals negative 40 plus 14x. So x squared equals negative 40 plus 14x. And this does not look like it should, right? What stuff needs to be next to each other so that we can complete the square? The x squared and the x's, right? Those need to be next to each other. So what should I do with the 14x? Subtract it over. Okay, so I'm going to minus that. I have x squared minus 14x plus something. So this is the side where we're going to be completing the square. And on the right side, I still have that negative 40 just sitting there. And now I'm going to go ahead and draw my square. So we've got x squared, and then how many x's go in each corner? 7. Perfect. So they're both negative. So what number completes the square? 49. And since we added 49 to the left side, what do we do to the right side? Add it there as well.
So it's going to be minus, plus 9.
Mm-hmm. So on the right side, that leaves us with a positive 9. What do we have on the left side?
Would we bring it x squared minus 14x plus 1?
Yeah, so you have x squared minus 14x plus 49. That's what you have. But we can write it as the completed square, right? What would it be as a completed square? Yeah, x minus 7 squared equals that 9. So now at this point, we're done completing the square, and now we can do the other part where we're actually using this to solve. So what could I undo to get closer to getting x all by itself? We can't get inside the parentheses just yet because they're protected.
Yeah, square root.
So we can square root it. So that gives us x minus 7. And anytime we are the ones who square root to solve a problem, we have to put a plus minus with it. Because you can have the positive version of the answer or the negative. So we've got plus or minus of the square root of 9. And what's the square root of 9? 3. So that means what we have is we've got x minus 7 equals positive and negative 3. We got two possibilities there. Okay. What do I do next? Well, we're trying to get x alone. How do we get that? Add the 7 over. Okay. So I'm going to say x equals, if I add the 7 over, I get positive 7, and then I've got plus and minus 3. You can see that? So I took the 7 and I added it over. And now I can go ahead and just do both of those possibilities. So I have x equals 7 plus 3, which is 10. And I have x equals 7 minus 3, which is... Did we say it? 4? Perfect. 10 and 4. And this is what I was telling you guys before, is that my preference is not to use this to solve. This is not my favorite. This one's not too bad, but when they start to get more complicated, they're not fun. So, but this is definitely a way that you can solve a quadratic. Do you guys remember what we're finding when we do solve our quadratics? The x-intercept. So this is saying if we were to go back and make this equation equal 0 in the beginning, then we could graph that and we would see x-intercepts of positive 10 and positive 4. That's what that means. Okay, we're going to do another example so we can see one that we'd have to plug in the calculator to get. We'd get decimals for. So we're going to say example 2. And example 2 is all sorts of messy when you start it. So it's x squared plus 23x plus 54 equals 5x minus 6. So it like really does not look like we want it, how we want it to look. So yeah, it looks weird, right? What do we want it to look like?
Or x plus x squared plus the x.
Yeah, we want x squared plus the x's all on one side, right? So what should we move first? Move the 5x? Okay. So if we move that, that gives us x squared plus 18. What do we want to do with that 54? Do we want it to stay where it is? No, we want to subtract it. So x squared plus 18x, and then we've got whatever would fill in the, or complete the square right there. What does the right side equal? Negative 60. Right. And what do we do next? Draw the square. Mm-hmm. Now what I'll say is those of you, some of you guys might have noticed that there's some shortcuts you can take, and there definitely are. What I would say is I do not want you to take any shortcuts until you can explain to me how the shortcuts work. Does that make sense? Because students who think that they're super good at this but aren't start to take shortcuts and then start getting every single problem wrong. Does that make sense? I want you guys, so this method is designed to like make you guys get it right every single time. If you just kind of walk yourself through it, it's literally a square, so it's helping you remember what I need to do to complete the square. You can do shortcuts, but I don't want you to do the shortcuts too soon and then just start getting wrong answers all the time. Okay? All right. So we've got the x squared. What should I put here and here? 9. So I've got 9x there and 9x over here.
81.
And right now my square equals negative 60. And what number would complete it? 81. So we added 81 to the left side. What should we do to the right side? Add 81. So the right side is 21. What's on the left side? X plus 9 squared. So on the left side, that's where we have our completed square written down. And what do we do to get closer to the x being alone? Square root. What should I always put in front of my square root sign?
Plus or minus.
Plus minus. So 9 equals plus or minus square root 21. And then how do we get x alone?
Try.
Minus the 9.
Okay.
So I've got x equals negative 9 plus or minus square root 21. So we have two ways that we can write answers for problems like this. We have exact answers and we have approximate answers. Do you guys remember the difference between those? Yeah. So our exact answer would be if we left it in the square root form, we get negative 9 plus square root 21, negative 9 minus square root 21. There's our two exact answers. And then our approximate answers are what we get when we plug it in our calculator. So let's go ahead and plug these in. We got 4 point. And let's round to 3 decimal places. So people, when they do approximate answers, they typically put a squiggly equal sign. That means approximate. It tells the person looking at your paper that you rounded and you cut off numbers when you wrote it down. If you guys don't write it like that, that's fine. But my answer keys often have that on there. I just want you guys to recognize what that means when you see it. So the first approximate answer is negative 4.417. And then the other one is negative 13.583. So there's our exact answers and our approximate answers.